Okay. All right, so we have to finish our 1.5 notes. Let me just talk through number 4. Um, Especially if we didn't do our homework, I'm sure we didn't think a lot about pre-cal over the weekend. And remember, this was kind of a new concept, so I want to make sure that we review it. And then I'll have you kind of try number 5 mostly on your own, and then I'll review it with you. So first thing we did was 4 and 5 are what we call parametric equations, which are two equations in terms of t. So it's x equals something with a t, and it's y equals something with a t. And t, our variable, is called the parameter. So t is called my parameter. The first thing we did, it asked us to find the points determined by t equals -3, -2, blah, 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 all the way to 2 and 3. So what we did was a little chart. We said, okay, we're plugging in for t, we're plugging in -3 all the way to +3. And we're going to see what our x's are for all of those t's and what our y's are for all of those t's. We're going to use those x and y's eventually, but the first thing we did is we found the x's and the y's. Okay. The next thing we did was we eliminated the parameter. I'm going to tell you right now, on any quiz or test, there will be a question on eliminating a parameter. There's not a ton of parametric equations that is super important to me, but eliminating the parameter is something that is important to me. So eliminating the parameter means that I am getting rid of t. I'm taking the two separate equations and using substitution, I'm going to combine them into one equation. So what I chose to do on this one is I took x and I solved it for t. So I took my x equals equation and I solved it for t. And then I replaced it for both the t's in my other equation. So I replaced, instead of having t, I had x minus 1 here, and I had x minus 1 in there. So we substituted in x minus 1 for t, and then we simplified it as much as we could in order to get a normal equation that had x's and y's in it. Okay, does anybody have any questions on that? If the y is easier to get by itself, get the t by itself in my y equation, you can do that. I just feel like the x one was easier, so that's why we did that one. Okay, next we sketched it by hand. I made us take the points, the x and the y points, and the one above, and we sketched it out. And we ended up seeing that it was the same thing as my equation above. The algebraic equation we found was y equals x squared minus 1, which we know is a parabola. It's a quadratic, and it's down 1. And that's exactly what the points that we found showed us. Everybody cool with that so far? Okay, the last thing I did is I showed you how to sketch this on the calculator. So we had to go to mode, and we had to make sure that we were in the parametric mode. So we had to make sure we were in the parametric mode, and it gave us two equations in one line. It gave us an x equals and a y equals. And then when I went to press my normal x button, I got the letter t, and then we graphed and we solved. If you forget that, we're going to go over that one more time. That is not a super important thing that I'm going to ask you, but I think it is really nice to know how your calculator works. I like to say probably the most useful thing I teach you in this class is how to use your calculator, because I find that you may never do pre-calculus again, you may never do rational function, there's a lot of things you may never do again, and that's okay, but using a tool or a program and making it do what you want it to do, like a calculator, that is an important skill you will take in the future. So we're going to do number 5, which basically is repeating all the steps from number 4 using two new equations. So my first equation is x equals 2t and y equals 3t minus 1. Now, my plan was to just be quiet for a minute while you do A and B at least, and then I'll put my answers on the board. Is that okay? Okay. I'll be quiet, and I'll do my work silently. Okay, I've essentially done A, B, and C. I'll do D with the calculator in a second. Go ahead and check your work. Does anybody have any questions on my chart or my graph yet? The next part's the eliminating the parameter, which I think is the most important part. Any questions on that? Is everybody able to solve one equation for T and then plug into the other one? Yeah, Megan.
You wouldn't simplify it to y equals x over 2 because
Y equals what?
x over 2. Or that's what I did.
Y equals.
Because I did like minus 1, so like 3 over 2 minus 2 over 2.
Oh, you can't combine those because this one is a coefficient for my x, so they're together. So what this essentially is this is an equation of a line, which is what I see right here, and this line looks like that. I love that you wanted to simplify it. I would say that you just can't simplify it any more than what you are. Great question. Okay, anybody else questions on what you see? Again, if you wanted to get the y equation, get that t by itself and substitute it in for the x, you're more than welcome to do that. I just think it's easier to get the x one by itself because there were less steps. We just divided by 2, and then I was able to easily plug x over 2 in for my t. What I'm about to do is go graph this in the calculator. I'm going to graph my original equations. X equals 2t and y equals 3t minus 1. And I want to see what I graphed by hand, which should be the exact same thing as if I graphed my 3 over 2x minus 1. You guys ready to go back to the calculator? Okay. I think I can share them both at the same time. Okay, cool. And so in case your calculator doesn't look like this, I'll just go backwards. If you hit mode and then the fourth line, you should have the parametric word highlighted. So if it's not, you can just do your little arrows over to it and then press enter to make sure it's highlighted. If you want to get out of this parametric mode, we should be in function. But we want to be in parametric. So now that I'm here, I'm going to quit out and I'm going to go to y equals, and you should have an x line and a y line. And mine are both blue. They're both the same color. So make sure you're not skipping around in your x's and y's. Make sure they're both right next to each other. And I'm going to write 2x for my first one and 2t and then 3t minus 1. And where did I find that t? What did I press to find that t? X, good. If you press your normal X button, if you see on the X button, the second letter is t, that's a variable we use in parametric equations. The next one's a theta, that's what we use in polar equations. And then the last one, n, is what we use in sequences. So we're able to solve doing that. Now, if you graph, I get my whole line that comes up. Do all of your whole lines come up? Good. If not, go to your window and make sure your t min is at least -3. I want to make my t min and my t max -10 and +10. What happens then is if you don't have that, basically you're only looking at like half of the graph, like you're only looking at this part right here. So we have to plug more t values into the negative side to get that part of the graph. Okay, anybody else questions on that? Nope, okay. We don't really need our graphing calculators today, so you can put it away. If you wanted to make sure it's normal next time you look at it, go to mode and make sure you go back to function. So if you want it to be a normal X, Y graph when you're done, go hit it function and press enter. I don't know if you'll need that, but sometimes people are like, we were playing around with our calculator last class and now I don't know what to do with it. So if you want to make it normal, just go back to function. But I'm going to be done with my calculator now because I'm going to get into 1.6. And like we talked about today, if you did not do your 1.5 homework, that is due next class. Okay. I just did my C and D up there, so I'm not going to worry about that. And did we do number 6? I somehow have mine erased. We did that though, right? Okay. We did this. All All right, let's go into 1.6. 1.6 is all about transformation. And we've done a tiny bit with transformations already where we just were doing like up and down with our BFF graphs and left and right. I want to remind us what all of our transformations are. So either above this, I'm going to put mine in like this area right here, or below it. It doesn't truly matter to me. I'm going to do this. I'm going to write a general transformation graph. I'm going to say y equals a f of x, f of b of x minus c plus d. This is where f of x is the function that's either drawn for us or given to us. If you notice in the two columns below, I have f of x written on my right-hand side with like things being multiplied by it or things being added or subtracted to it. So I want to talk about what do those numbers mean. Okay. The first thing I want to do is what I think is the easiest one. This d that's being added or subtracted to the end, if I add or subtract any number to the end of my function, what does that do to my graph? Moves it up or down. The right or left will be next, okay? And up or down is exactly what you think it should be. So if it's a positive, it's moving up. If it's a negative, it's moving down. So I like to remind myself it's exactly what I think it is. Now, Michael, which letter tells me when it's moving left or right?
C.
C. Good. So if it's inside the parentheses with x, if it's under the square root or under the absolute value, or if it's inside with the x, that moves it left and right. When it's negative, which direction does it go?
Right.
Right. When it's negative, it goes to the right, and when it's positive, it goes to the left. I have to remind myself it's opposite of what I want. I want the right to be positive, but it's not what I want. It's opposite of what I want. Everything that's in the parentheses is opposite of what you want. So I guess that being said, we'll do B next. B deals with horizontal stretches and shrinks. That means it physically, like, it compresses it in like an accordion, like in like this, or it stretches it out long ways, okay? That affects my x. I wanted to write something down to make sure I'm saying all I said. Okay, the B changes your x's, and you can think about it doing the opposite of what you want. So this B right now is being multiplied by my x. It changes my x's by thinking about dividing all your x's by 2 or by B or whatever it is. If it's dividing, then we multiply, but it does opposite of what we think. I might even write that, opposite of what I think. We still at this level do not do a lot with B, but I want you to know that it's opposite of what you think it should be doing to your x's. Okay. And then also the negative in here, if there's a negative with my B, what does the negative do to my graph? It flips it. I'm gonna tell you, I want us to think about it flipping it this way across my y-axis. So I'm flipping it like this. In a minute, we'll do the A where it flips it the normal way. So it's gonna flip around the y-axis. Any change with B is the hardest thing. So we're gonna do a few normal changes and then we'll get into some B changes. But I think C and D are the easiest. I think A is the next easiest. I think B is the hardest. Now that we've been kind of talking about this A, like very generally, A changes it vertically. So it's a vertical stretch or shrink. So it essentially, I'm on like on top. It's like I step on it and make it flatter, or I can stretch it long way. So it stretches my Y's. So whatever your A is, think about that A being multiplied by your Y's. It changes your Y's. And when I have a negative in front of the whole thing, that also flips my function. but I want us to remember most of the time when you guys tell me to flip it, you do one of these little hand signals. I know my YouTube friends can't see it, but it's flipping over the x-axis. So it flips everything from positive to negative or from negative to positive. So it flips over the x-axis. So now basically what we're going to do is kind of take a nonsense graph and we're going to take all those points and we're going to do the transformations. There's a couple different ways you can start these. I'm going to show you one way that I think is the most foolproof way, but if you want to do a shorter cut to that, you are welcome to. Okay. In order to do the transformations, I want to know what my original points are. So the very first thing I'm going to do is make a T-chart with all of my points that I physically see here. And that's my original T-table. So I'm going to make an original T-table over here with all my X's and Y's. What are the points that were given to me? Because we're going to change all of those points. Okay. So the first point I see is at -2, -3. Then I see one at -1, 0. I see one at 0, 1. I see one at, oh, sorry, I saw one at 0, 1, and I see one at 1, 0. Sorry, almost the same point, just a little flipped. I have one at +2, -2. I have another 0 at 3, 0. And last I have 4, +2. All I did was I just listed all my points off to the side. No, you don't have to do this. I'm just showing you this is what I think is like the most foolproof way of doing it. I personally have a little bit of trouble with transformations. Sometimes I like get all bent out of shape or confused in my head. So I like to just like list things out as much as possible. Okay. Now for each one of these, I'm going to take this original T-table and I'm going to alter it depending on what my transformation is. So the first one, letter A, says y equals 2f of x. So what spot is that 2 in? It's my A. It's my A. So that means it's going to, oh, I used the wrong color. It's going to stretch or shrink my graph vertically. When you have a 2 out front, that's the same thing as doing 2 times all of my y's. The x's will not change. The only thing that changes is all my y's are going to get multiplied by 2. So instead of being at like -2, -3, it's going to go all the way down to -2, -6. I am going to draw a new graph and I am going to make a little T-table with my transformations here. Again, if you can do the transformations in your head, you don't have to do a T-table. I'm afraid of messing up. I'm going to do a T-table. So instead of my first point being -2, -3, it'll be -2, -6. Now, anything times 0 stays 0. So all my zeros stay the same. The next point, 0, 1, becomes 0, 2. Notice that none of my x's are changing, only my y's are changing. Then 1, 0 stays the same. 2, -2 becomes 2, -4. 3, 0 stays the same. And then last 4, 2 becomes 4, 4. Okay, now that I have this chart, I'm gonna go graph it. If you want to, you can put it on top of the original graph. I'm going to make a whole new chart because not every time will we be able to graph on the original graph. Okay. And then once I've got my chart set up, now I can just graph those T points. So -2, -6, -1, 0, 0, 2, 1, 0, 2, -4, 3, 0, and then 4, 4. You can't truly tell because it's not on the same like scale as your other one was. But basically, if you humor me and let me draw it on this, on top of the graph we were just given, it is stretched by a scale of 2. Do you kind of see the difference?
Yeah.
Okay. Again, if you don't like doing this little T-chart, you don't have to do it. But if you have trouble, I suggest you doing it. If you don't use that T-chart, then I would go to each point and be like, okay, I was at -2, -3. Now I gotta multiply that y by 2 and just do each point in my head like that, okay? They got sent to lunch early. You guys can go, but I'm teaching at 12:45, so be here on time. Have a good lunch. Pause this and come back.